Hi everyone, today we are going to learn symmetry of elements. Symmetric element is a geometric figure like a plane and a center. Element of symmetry is one of the most important methods to determine whether the molecule is symmetric or asymmetric. This line says that the element to divide equally or not. That actually, if we say that what is symmetry? Symmetry means when we take any particle or a substance, it has to divide into two equal parts. That means like a mirror image. It is a test in which the mirror images are superimposed to check optical activities of a molecule. That means we can check the optical activities of a molecule by the symmetry of element. When the center part of a molecule are interchanged with other parts, that means when the electrons are interchanged with attracted by other electrons, that results in forming a new molecule which is indistinguishable from the original. Then the molecule is said to have symmetry elements. Each and every chiral molecule exhibits the property of optical rotation. That means every chiral molecule can have the optical rotation. In certain molecules like tartric acid, and because of presence of two chiral carbon atoms, the optical activities gets nullified due to internal compensation. And this is an example for symmetry element. Tartric acid is taken as example. Now we will see that types of symmetry element. There are five types of symmetry elements. They are rotational axis of symmetry, which is also known as axis of symmetry. First one, I will repeat it once again. Rotational axis of symmetry or axis of symmetry. Rotational axis of symmetry or axis of symmetry. Second one, plane of symmetry. That means mirror plane. Second one, and third one, improper rotational axis of symmetry or rotational reflection axis of symmetry. And this improper rotational axis of symmetry can also known as alternating axis of symmetry. Inverse center of symmetry, and last one is identity. And now we are going to read types of rotational axis of symmetry. It rotates the molecule about the axis of 360 degrees. That means when we take a molecule, that will be rotated about its axis, on its own axis, about 360 degrees, where n is represented as a fold axis and further classified as two-fold axis, rotational axis of symmetry, three-fold rotational axis of symmetry, four-fold rotational axis of symmetry, multi-fold axis of symmetry. And now we are the second one is plane of symmetry. Plane of symmetry. It is an imaginary plane that bisects the molecule into two equal mirror images. That means when this plane bisects any molecule, that will be divided into two equal parts, and this plane is imaginary. This plane may pass through or bisect a molecule or an atom, or it may pass through two or both molecules. That means it can be divides the two molecules into equal parts, or divides the two molecules into half of parts. All the atoms of a molecule present in the same plane definitely possess at least a single plane of symmetry. Example, you can take H2O. H2O, that means water, plane of symmetry, or 2-chloropropane. And And the plane of symmetry I divided it into two parts. That is rectangular plane of symmetry, diagonal plane of symmetry. Rectangular plane of symmetry will be represented in the figure 1, and diagonal plane of symmetry is represented in figure 2. And we go to the third part, that means improper axis of symmetry. Improper axis of symmetry. It is also known as an alternating axis of symmetry or rotational axis of symmetry. As further I told that the improper rotational axis of symmetry is known as alternating axis of symmetry. You can see that it is given here clearly. This is also common. This is also a common feature of a molecule which contains ring system. That means this molecule contains a ring system, and it is very rare in other systems. In this, the molecule is made to rotate in clockwise. That means how the clock will rotate on its own axis around. In the same way, the molecule is said to rotate around its own axis and at an angle of 360 degrees, and then reflected in a plane perpendicular to its axis, where n represents the order of the axis. It finally results in no change of a position of a molecule, and the molecule comes to its starting position. That means there will be no change in the molecules that comes to its original position, because it is rotated in 360 degrees on its own axis and it is perpendicular. This is an equivalent configuration is produced since the operation involves the rotational molecule followed by the reflection. It is also known as rotational reflection axis of symmetry. And now we go for the fourth one, inverse center. It is also known as a center of inverse or center of symmetry. It is a point in the center of a molecule, and any line drawn from this point finds a similar environment in the opposite direction. That means when we take a point in a molecule, if we draw a line opposite to its direction, we can find the same environment or a same element or same energy level of a molecule can be found in that position. In other words, a molecule in which the straight line is drawn from its center meets the identical atoms at equal distance from the center is said to have a center of symmetry. It is said to have a center of symmetry. That means when we take the center of if we take example of a SF6, when we take S as a center, then if we draw an opposite line